Hey guys, what's up? This is Alex2K and today we're talking about fluid basics. So fluids, there's two types. There's 3D fluids and there's 2D fluids. Right, so pretty much the main difference between both is that 2D fluids only have X and Y, whereas 3D fluids have X, Y, and Z. So of course, 3D fluids are a little bit more computationally expensive than 2D fluids. As far as their composition, 2D fluids and 3D fluids are made up of particles. Alright, so if this is a fluid container, like that, then each one of these guys is a fluid particle, and those particles are called voxels. Alright, so whenever you hear someone talking about voxels, they're talking about fluid particles. So that's one of the main things here. So one more thing when you want to play with fluids, a good place to start, of course, is the might help, but you can also go and get a fluid example. So let me just wait up for my visor to open up here. There we go. And there's these little examples that you can always check out and see how they work, So what's cool about this is that when you select the fluid, you'll see these notes, and it's a pretty helpful way to understand some of the things that are happening on the fluid. That way you can make some good use of them. So there's just a little sample fluid right there. So you can see, oh look, cigarette smoke. Alrighty, so let's start talking about fluids. You can access them by going to Dynamics, Fluid Effects, and there's the 3D containers and there's the 2D container. So let's start with the 2D container. So there it is, and if I press play, nothing's going to happen. Alright, so the first thing you want to check always with Dynamics is make sure you're playing back every frame. That way your computation is correct. And as you can see, nothing's happening. The reason why nothing's happening is because there's not an emitter in this container yet. So you can add an emitter by going Add Edit Contents Emitter. Alright, just in case if you want to make it with an emitter, there's the container with the emitter. But I like doing it like that. Let me delete that. Fluid Effects, Add Edit Contents Emitter, and let me just go ahead and reset my settings. There we go. So it just added an emitter on there, and if we press play, this is the wireframe display. But once you press 5 or 6, then there's your fluid emission. Alright, so it's pretty straightforward. Now what's happening right now is there's all these settings that are making the fluid behave the way it is. So, one thing to note is that you can't move this guy out because then it's not going to work. So you're always going to make sure that the emitter is inside of the container. Okay, so just like with any emitters, you already know about emitters, so you got the properties. But these guys have, instead of rate, they have this density, heat, and fuel. Density, voxels per second. What we're seeing here is density. So if I take the density down, then nothing is being emitted. But if I increase it to 1, then there's some density. And if I increase it to 5, then there's more density, and so on and so forth. 10, that would be like really dense. And something that is kind of cool about this, guys, is look at the size of the emission. Alright, it's like that's the size of this emitter. Well, if I take that maximum distance down to, let's say, 0.1, then it's actually emitting from a smaller area. Okay, so that's always something handy to keep in mind here when it comes to fluids. As far as the fluids go, just the basics of them. They have a resolution and a size. It's always best to change the size by changing the size rather than scaling it, because it is a fluid. So if you change the size by scaling it, you're just scaling the whole thing. Whereas if you're changing the size by changing the size, you're actually giving it more area for it to compute. So it's not, it's not scaling. It's actually just making it bigger. There's this resolution, and the best place to check out that resolution, I'm going to change the display settings here. so that the wireframe display is rectangles. So if I press 4, this is what we used to have, these little particles there. I'm just going to switch it over to rectangles, and what you can see there is each voxel as it's being simulated. So right now there's 40 voxels by 40 voxels. That's what that resolution is saying. So if I made it, say, let's say 30 by 30, of course it's going to be smaller, but there's 30 voxels across and 30 voxels up and down. So if I make it twice as much, then there's more resolution, and you can see that. So of course the fluid resolution is going to increase and it's going to look a little bit nicer. When it comes to the display, there's also this boundary draw. Right now it's set to outline, but if I set it to full, then you can see each voxel there. Each one of those is a voxel. And let me just change the resolution again just to emphasize what I was just talking about. So now it's got less resolution. Now the voxels, you want to keep them square rather than rectangular, because it's just gonna look more natural. Because if this was like that, then it would be like a weird looking fluid. See how it stretches out? So you want to keep them square. Back in the display, you can also do bounding box, and it's going to draw out this little bounding box. Or you can do none, which is not going to show it on the display, which is kind of cool because that way you can see what's happening, but on the downside you don't know what you're selecting. So I'm just going to keep it as outline. Okay, so go ahead and select this emitter, and we're going to increase the density to 5 so you can see it better. Now, as you can see, what's happening in the fluid is that it's containing itself inside of that container. And the reason why that's happening is because of the settings of the container. There's a boundary, and you can change the boundary to whatever you want. So if you want it to none on the X and Y, what's going to happen is, this fluid is just going to go up, and once it gets past that point, it's still going up, but it's just not showing it. If we do wrapping, for example, that one's pretty cool, because then once it gets there, it starts going back down, and after some time it starts sort of like repeating itself and speeding up. Let me just increase that time a little bit more so you can see what's happening. More and more and more and more and more and more. So it just starts wrapping around. And you can see how it starts speeding up because each particle is pushing the next particle and so on and so forth. So it's kind of interesting. So the question is, so why is this going up? The reason why this is going up is because of a value called buoyancy. The way that this is broken down is you got the container properties, you got the contents method, and you got this display settings, and then you have dynamic simulation and content details. On the content details, you'll see density, velocity, turbulence, and temperature, and fuel, and color. Density, velocity, temperature, fuel, and color. Right? So it's a lot of back and forth whenever you're playing with fluids. Now, right now, what's being evaluated is the density and the velocity. If you see, the temperature is set to off and the fuel is set to off. If it's set to dynamic grid, that means it's computing dynamically, so it means it's dynamic. If it's a static grid, it's not dynamic, and if it's a gradient, of course, it's not dynamics. So I'm going to keep those two as dynamic grids, and keep in mind that we're talking about density, and the velocity needs to be dynamic so that it computes the velocity over time. So back on the dynamic simulation, you'll see your settings for gravity, for viscosity, friction, and damping. This is a fluid, so viscosity makes sense to be there. And under content details, you have the specific details for density and for velocity and for turbulence in this case. So if I increase the density scale, let's say to 5, then it just looks more dense. But the best thing to do is to keep it at 0.5. Try not to get too crazy there. And the buoyancy is what makes the fluid go up. So if I put that 0, then this little emitter is emitting, but there's no buoyancy, and if it's negative, it's going to come down. So what if we make it come down, and let's just change these boundaries back to both sides. So what's going to happen is this guy's going to come down and just spread out, kind of like a mist. So it's pretty handy stuff there. There's a value for dissipation and for diffusion. So what I'm going to do is I'm going to change the settings of my emitter. I'm going to give the maximum distance back to 1, so it's a thicker cloud of smoke there. And it comes back down, and you can see what's happening there, right? So let's go ahead and take a look at what the dissipation and the diffusion. The dissipation is going to dissipate the fluid over time, so it's dying out, and the diffusion is going to soften it, so it looks more cloudy, more misty. So you can play with those values. And then the velocity scale and the swirl, particularly the swirl will give these swirls. Now we can't really see too much because we don't have a lot of resolution, so I'm just going to increase this resolution up to 120 and 120 just so you can really see that. Take that diffusion back down. You can really see those swirls happening. It's the vorticity of it happening on the fluid. Let's give it, just going to increase the dissipation so that they die out and they don't live forever. See how they're dissipating before they get down there. Okay, so that's what that swirl value does. And you also have a turbulence. I'm just going to take this back down to 0, rewind and play back again. So it's just a normal coming down. And if we increase the turbulence, then it's almost the same, but it is actually turbulence, so you can see how the turbulence values are changing the behavior of the fluid. We don't have any temperature or fuel, so we're not going to play with those guys, but just so you know, there's the scale, the buoyancy for temperature, and so on and so forth. And color, we don't have any dynamic color, so we can't really change any value there. Then we also have the shading properties, and that's where you can change some of the main shading properties of a fluid, such as the color over time. So you can change the color over, let's say, density. So it starts with one color and it ends with another color depending on the density of it. Just move this guy over there. So wherever it is more dense, it's going to be white, and wherever it is less dense, it's going to be red. So it starts getting more red as it becomes less dense. And incandescence is really based off of temperature, so we're not going to change that. And the opacity is also, you can also change it, but set to density, so of course you can always change this value, so you can change how the transparency is being computed. So of course, if we make it all solid, then there's no opacity there, and you can always scale that opacity down. And there's this bias, so you can bias that in and out. So those are some of the main properties of the fluid. Let me just show you a couple of things that are kind of interesting about fluids, just for their basics. Take that buoyancy level back up, and we got that. Let me take the color and just make it regular white, like so. Now if you look at the color value right now, the color computation contents method, the color is set to use shading color, but you can also make it a dynamic grid. Now check this out. If you select the emitter, see it says emit fluid color. So if you check that, it's going to tell you, dude, your color method is not set to dynamic grid, and you need it to be dynamic so that it computes. So it's just like, okay, do it for me. So just change that setting to dynamic grid, And if I give it a color, then now my fluid is emitting with that color. And of course, that's also being weighted with, where is it at? There you go. Color method, you can see is set to dynamic red. Now, if you need to add more emitters, or you want to move emitters, you can totally do that. But if you want to add more, it's just a matter of selecting the fluid and add another emitter. So now there's 2 emitters. And again, back on this guy, I can increase the density, let's say to 5, change the color to red. So now I got 2 fluid emitters. They're doing their thing. And they start to get, they start to combine. Now what's also interesting about fluids, let me just get these 2 guys. This guy has a density of 5 voxels per second, and this guy, let's give it a density of 1 voxel per second. So see how the one that has more density pulls the one that has less density? If I take this back to 5, then it's like they're blending differently. If I make this one 10, then sort of like the opposite's going to happen. The one with lesser density is going to try and stick to the one that has more density. That's just the way nature works. So it's pretty exciting. And furthermore, you can add collision objects. So if I have a little object here, as long as it's penetrating that geometry, then that fluid. Just go ahead and select this fluid emitter and select this fluid emitter and put this geometry over here. Let's just rotate it up like that, duplicate it and rotate it like that, or actually let's just rotate it like that. And you can tell these guys to collide. Select the fluid and the object, and fluid effects, make collide. And same thing there, fluid effects, make collide. So now those fluids are colliding with that surface, which is kind of neat. Of course, those surfaces can be animated, and we're going to change their behavior. So you can see it's kind of cool. You can do pretty cool things with this. Alrighty, so that pretty much takes care of some of the major basics of fluids. You got the resolutions, you got the collisions. There's a lot more things you can do to it, but I'm going to keep this tutorial short and sweet. So I'll see you next time with another tutorial. Bye.